on the back, we are going to talk about solving a quadratic equation. A quadratic equation is just an equation that contains a squared term. So basically, anything that has an exponent of 2 in its equation is considered a quadratic. So an example might be like 8x squared plus 3x plus 5 equals 0. This is what makes it a quadratic equation. Right? It could have more terms, it could have less terms, but as long as it has a term with an exponent of 2, it's a quadratic. All right, so first they ask us to solve examples A, B, and C. So if I am to solve for x, my goal is to get x by itself, right? So on A, what would you guys want to do first if we were trying to get x by itself? Subtract 5, very good. So if I subtract 5, then I'm going to have x squared is equal to what? 24. All right, and I want to learn the value of x, not x squared. So how would I get rid of the square? Take the square root. And we would have to do that to both sides of our equation, right? Okay, what's important to remember here is that whatever our square root is, it could have been made up of 2 positives or 2 negatives, right? Because 3 times 3 would give me 9. But negative 3 times negative 3 would also give me 9. So negative 3 or 3 could have been the square root of 9. Same is true here. It could have been the positive or the negative value of the square root of 24. Now, is there a perfect square root of 24? No. But we learned on Friday how we can simplify this, right? Is there anything that would multiply to give me 24 that has a square root? What would that be? 4 and 6, right? And what is the square root of 4? 2. So this would be the positive or negative value of 2, and 6 does not have a square root, so 6 would stay under the radical, right? Okay, because we came up with 2 answers here, we did come up with 2, right? Positive 2 square root of 6 and negative 2 square root of 6. It's important for us to realize that if we were to graph this, it should intersect our x-axis in 2 places because we got 2 answers, right? Okay, so intersects graph twice. Okay, part B, same idea here. We're trying to get x by itself. What am I going to do first? Add 4. So I'll have 3x squared equals 0. Good. All right, and then what should we do? Divide by 3. Good. And 0 divided by 3 is still just 0. And how do I get rid of the square? Good. Okay. And our answer is still positive and negative, but is there a difference between if I put plus 0 or minus 0? No. So it would just be 0 here. So how many answers did we get this time? Just 1. So how many times would this one intersect the graph? Once. Good. So this one would just be once that it intersects. Okay, one more. On example C, what should we do first? Good. So I have negative 6x squared is equal to that 18, right? Then what should we do? Very good. And what is 18 divided by negative 6? Good. So we do get a negative there. Then what should we do? Take the square root. Okay, the problem here is there anything you guys can think of that multiplies times itself to give you a negative number? No, right? If it multiplied to give me a negative, it had to be one positive and one negative. But unfortunately, that's not what squares or square roots mean. It has to be the same number, right? So you can't have the square root of a negative number because there is nothing that multiplies times itself to give you a negative, right? Like if I asked you the square root of -9, our only two options are 3 times 3, which wouldn't work, and -3 times -3, which still wouldn't work, right? So in this case, since the square root of -3 is not possible, it's actually what we call an imaginary number, which we'll talk more about in Algebra 2. But in this case, since we didn't come up with a solution or a real number solution, would this one intersect our x-axis at all? No. It would still be a parabola, it just means it never touches the x-axis. It's either above the x-axis or below it, it just never touches it. So it would not cross the x-axis or doesn't intersect. Okay, so this is great when it works out that we can find some value for our answer, but there are some circumstances where that doesn't work out, where you don't get a nice, neat number, and you need to know the exact decimal or whatever it may be where you're crossing, okay? And if you can't solve it like we did up here, we use what we call the quadratic formula, okay? And if you guys remember, the quadratic formula is that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And remember, anywhere there's an a, you're going to substitute in the term that's with your x squared, the coefficient, right? Anywhere there's a b, you substitute in the coefficient that's with your linear term, x. And anywhere there's a c, you substitute in your constant. If any of those things are not there, they're understood to be 0, right? If they're not part of the equation at all. Okay, so we've gone back over what the quadratic formula is. Let's look at an example. It says to use the quadratic formula to solve the equation 8x squared is equal to 1 minus 6x. And leave your answer in simplified radical form and also an estimate to the hundredths place. So we're going to give our answer two separate ways here. All right, before we can get started, if you look back up here, this equation is in standard form, right? It's all on that one side of the equation. So my current equation is 8x squared equals 1 minus 6x. And I need it to look like this. So I need it to all be equal to 0. So I'm going to have to move some things over to make that happen, right? All right, so what should we do to move everything over there to the left? Okay, we could if we wanted to move to the right. We typically want to keep our lead coefficient positive, so if you do move that over, go back and divide by -1 to fix it. Or in this particular case, you could move everything over to the left, right? If I wanted to move -6 over, how am I doing that? Adding it. Okay, and if I want to move +1 over, how am I doing that? Subtracting. Okay, so whenever we rewrite our equation, make sure you write it in descending order by exponent value. So you're going to write down your quadratic term first, which would be your 8x squared. Then your linear term, which when I moved it, I added it. So it became positive 6x. And then your constant, which we moved by subtracting. So now it's a negative instead of equal to 0. All right, then it's our job to determine which values we are going to use for A, B, and C. Remember, A is the term with your squared term or your quadratic term. So what's our coefficient for that? 8. Good. All right, my linear term determines B. What's its coefficient? 6. And what would my constant be? -1. Good. All right. Now it says to use the quadratic formula to find these solutions. So I'm just going to use that formula from up above, plug in all these values, right? Okay, so I'm going to have x is equal to negative b. And what did we say our b was? Good. Plus or minus the square root of b squared, which you guys already told me was 6. Make sure you put whatever it is that you're supposed to be squaring in parentheses, because if you type it in your calculator and it's a negative without, it won't catch the negative. Okay? Minus 4 times a, what's our a? Good. Times our c, which is good. All over 2 times 8. Okay. So now we have it all substituted in. We just need to go back and simplify. Okay, like we said up above, if you end up with a negative underneath here, that's an imaginary number, not real, right? So that's the first thing you actually want to check for. Make sure you're not getting a negative underneath here, because if so, we're not going to have a solution anyway, all right? So underneath here, I've got 6 squared, which would be 36, and then I've got multiplication over here. So I've got -4 times 8, which is -32, and -32 times -1 is 32. So I have 36 now plus 32, right? What is 36 plus 32? 68. So this became -6 plus or minus the square root of 68 all over 2 times 8, which is 16. Okay, so remember, it did say that it wants our answers written 2 different ways, right? First, in the exact radical form. So we want to see if we can simplify that square root of 68 any. So is there anything that multiplies to give us 68 and has a square root? Good, 4 and 17. So I can rewrite this as 4 times 17 under that radical. Okay? And the square root of 4 is really just 2. Okay, so let's go just a little bit. So I would have -6 plus or minus 2 square root of 17 all over 16, right? Those coefficients are whole numbers. We've got -6, we've got 2, and we've got 16. Can I simplify those all by some number? By what? 2. All right, so I could simplify this down to, if I divide -6 by 2, it becomes -3, right? Plus or minus 2 divided by 2 is just 1. So you can put 1 square root of 17, but it's kind of like putting 1 in front of x, right? You don't need it. And then 16 divided by 2 gives us 8. And now we have simplified our radical as much as we possibly can, because there is no square root of 17. So this would be our exact radical form, okay? They did also ask us for the estimate, and I put the calculators up because we had a debate tournament this weekend. So if you guys want to go grab yourself a calculator real quick so you can type it in. Calculator. Alpha, the green button over here. Y equals this button on the top row. And then press enter. And then it's going to allow you to type as a fraction. Everybody got that? Okay. So we are going to have to type this in our calculator 2 separate times because there is no button for plus and minus, right? So for the first time we type it in the numerator, we're going to put in -3 plus the square root of 17 all over 8. Press enter, and there's our first solution. So what did we get there? Rounded to the hundredths place. Point what? Okay, that means type something in wrong. Check with your neighbor. What decimal did we get there? Okay. All right, we got to do it again, though, for the minus in there. So I'm going to do it again. Alpha y equals enter, so that I'm typing as a fraction. -3 this time minus the square root of 17. And then in the numerator, in the denominator, we got that 8. This time, what did we get? Good. All right. So this right here was our exact answer. This right here is an estimate answer. Okay? If you wanted to check that your answers were correct, you can go into your calculator, into y equals, and type this equation in y1 and check to see if the two answers we got are where it crosses the x-axis. Okay? Now on a quiz, that's great if you want to check your answer that way, but I am going to be looking for you plugging it into the quadratic formula. You do not have to have the quadratic formula memorized. I will provide that for you, okay? But you just need to know how to substitute it. All right?